Hey guys, it's Mr. A here with our next trigonometry lesson in grade 10 academic math. Uh, basically the first four lessons of this unit, just as a quick recap, we started off with similar triangles. We saw how if two triangles had all the same angles but different side lengths, they would be considered similar triangles. And through the corresponding side ratios, you can actually find out some missing sides or unknown sides. And so that was our first tool of this unit. And then we got into trigonometric ratios, which basically it's only worked with right triangles. So triangles had to have a 90-degree angle, and by labeling the sides as hypotenuse, opposite, and adjacent sides based on the angle you're interested in or using, you can come up with one of three ratios. And we had special names for the ratios: sine, cosine, and tangent ratios. And using the calculator, we can actually set up equations and solve for missing sides and missing angles in a right triangle. So, and then the last lesson, we looked at a couple of slightly more complicated word problems where you've got a couple triangles kind of connected together that are right triangles. So that's where we are now. So I mentioned on one of the earlier lessons that there'd be different tools that we are going to learn for triangles that don't have a 90-degree angle. So that's where we're starting today, and that's the first tool. If you see a triangle that's not 90 degrees, not a right triangle, that the first tool we'll try to use is called the sine law. Okay, now this is different than the sine ratio, the trig ratio. This is actually an equation that uses the sine function, but it's different than just the sine ratio. It's not opposite over hypotenuse. It's using ratios. Okay, ratios of sine equation. So let's derive this formula. I'm not going to go deep into it. For those of you that are interested, I'll attach a link to a video as to where does this come from. And actually, it's kind of cool the way this is derived. It's actually using a triangle that looks like this with this side here, the height of a triangle. So this is the non-right triangle we'd be looking at. We got vertices A, B, and C, and we're going to label the sides as to we did this I think we did this earlier on. Basically, if you have vertex C, the opposite side is little c. If we have vertex B, the opposite side is little b, and opposite angle A or vertex A is little a. So that's how we kind of label this, and it's very important because you can see in these formulas, you've got capital A's, ABC, and little ABC. Well, the little ABCs, those are the side lengths, and the capital letters are the angles at the corners of the triangle. Okay, so the proof not the proof, the way this formula equation comes up is based on looking at this triangle ABC and actually drawing a line down the middle that makes it into two right triangles, and then from that we actually can kind of come up with this using the trig ratio. Okay, so if you're interested, have a look at that. If you're into math, hopefully you are a little bit, and have a bit of time, you'll see how that's come up with. And a lot of students I tutor, the teacher actually asks them to prove that this is true. So it's not out of the possibility that you'd be expected to know how to do that. Okay, who knows? Maybe I could assign that as an assignment question this week. Okay. Now, so if we look at the ratio, let's just go down to this version here. So it's the ratio of the side A, which is this length here, over the sine of this angle. So you can see it. The formula is not hard to remember because you got the letters match up, the capital and the small version. So it's side A over sine of angle A is equal to side B over sine of angle B is equal to the length of side C over the sine of angle C. Okay, This is reminds me a little bit about when we did similar triangles. You got three ratios all equal to each other. Okay. Now when we actually use this, we're only, just like we did with similar triangles, we're actually only just going to use two of these three ratios, and it'll be pretty obvious which ones we use once we get to that problem. Okay, now there's actually two versions of this formula if you look above here. So the one we just talked about is the first one. If we flip everything upside down, if we put the sine of the angles on the top and the side lengths on the bottom, that this is also true. So you could use, you'll use either version here. And when do you, how do you decide which one to use? Depends what you're looking for. If you're looking for a side length, it's always best to have the unknown on the top, okay, in the numerator part. So if you're looking for a side length, you would use this version. So for side, let me do this, unknown side, you'll use this version, and an unknown angle, you'll use this version, okay? Now, if you forget and use the wrong version, will it work? Yes, but it works. It's always nicer to not have to solve for a variable on the bottom compared to having the unknown on the top, okay? Now, the thing about this rule, okay, whenever we solve an equation, we can only have one unknown. So that kind of implies, at the very minimum, well, for sure we have to know one of these three complete ratios. So how will you know if you can use the sine law? Well, the first thing you look for is, do I know an angle and its opposite side? It could be any of the three. So you're looking, do I know a pair of angle and the side? And that's called a complete ratio. So that's the first thing you look for. And then what do you need besides that? Well, you just need one other piece of information. It could be a side, it could be an angle, but you have to have, say, one of these four things. So, for example, if I knew angle A and angle B, and I knew side A, well, then I can figure out what side B is using sine law, okay? And of course, if I know angle A and angle B, well, that also gives me angle C, because angle C would just be 180 minus these two. So anytime you know two angles of a triangle, you basically know three, because you know the third one is 180 minus those two angles, okay? That's not true of the sides, though, okay? If you know two sides, that doesn't just, you don't know what the third side is necessarily, okay? So again, the first thing you check for, can I use the sine law? Because there are going to be some cases where you can't. You look for, do I know a side and its opposite angle? Could be any of the three. And if I know that, do I know one other piece? Do I know a side or an angle? And if I know those three pieces, then I can use the sine law. Okay. Hopefully we'll check that out as we do these questions. I'm only going to do two little word problems to demonstrate how to use the sine law. There's lots of questions in the homework where it's just, here's a triangle and then find this side, okay? This one I used the two word problems in the examples from the textbook. So these are actually in the textbook. If you just, homework was on page 402. I'll just show you here. If you just go back a few pages in the textbook, you'll actually see these two questions, okay? All right, so now this diagram was provided because it's kind of a weird worded question. So you got a bicycle path. So here's the bicycle path here. Bicycle path forms a 66-degree angle with one lock of a canal. So hopefully you know a canal is basically a waterway with with a lock at each end. A lock basically can raise or lower the water level in between, so that the boats that travel in the canal can basically get up and down to the next body of water. Okay, so there's the first lock, there's the second, there's the waterway. So this bike path, which goes 66-degree angle to one of the locks, okay, and it's 2.5 kilometers. So if you travel 2.5 kilometers and you look to see what the angle to the next lock was 52 degrees. Okay, so this kind of this is right in what I was just talking about. They gave us two angles, and that automatically gives us the third one. So I'll just show how that comes. Angle C. Actually, I got to label these, right? I'll call that A, B, and C, and that's important. Like a lot of these questions, you're not going to have side names or angle names, so it's up to you to just pick some letters so you can use the formulas properly. Okay, so ABC. So angle C is basically 180 minus 66 minus 52, and that works out to 62 degrees. Okay, so I can go back, put that right in the picture. So now I've got all three angles and I've got one side. And so at this point we would check to see if we can use the sine law, because obviously this is not a right triangle. I can definitely not use trig ratios. Okay, don't even think about using trig ratios on any non-right triangle, because, well, the first thing that would go wrong is, where's the hypotenuse? Well, there is none, because it's not a 90-degree triangle, so everything falls apart pretty quickly. Okay, so if I'm looking at this, I've got three angles, I got one side, so I ask myself, do I know a complete side angle ratio? Meaning, do I know a side and its opposite angle? Yes, I do. These two here. And do I know another piece of information? Actually, I do. I know two other pieces. I know both the other two angles, so I can definitely use sine law for this. Okay, so the question is, how far apart are the two locks to the nearest tenth of a kilometer? Okay, so where is that? The two locks are along here. So I'm looking for this. Now I could call that x, but I'm going to stick with the naming convention. So that would be actually little b. That would be little b, side b across from angle b. So if I'm doing my setting up my sine law equation, well, the unknown that I'm trying to get is b. So if you go back to your two choices, I want to use this version because the unknown is on the top. So I'll start off with the, I won't put any numbers in yet, but I'm going to use this ratio here. So b over sine b, capital B. This is what I'm trying to get. I know that. Now the other ratio has to be the complete ratio. So that would be in this case, the only side I know is this, and this side would be called little c because it's opposite angle C. So the other ratio would be side C over sine of angle C. Okay, so I'm not even going to bother with this combination here because I don't know that side length. So I couldn't possibly use that because then there'd be two unknowns. Okay, now you can see how important it was for me to actually figure that out, to actually calculate that third angle here, because if I didn't do that, I'd be looking for the side angle combination, the complete ratio, and there would be none, because the only side I know would be this, and if I thought I didn't know that angle, I couldn't use the sine law. So if you didn't do this step, the 62-degree angle there, you would be stuck because you wouldn't be able to use sine law because you didn't calculate angle C yet. Okay, so there's the ratio we're going to use. At this point now, I'm just going to plug in the values we know. So B is still what we're looking for, and then angle B is 52, so that's sine 52 is equal to side C, which is 2.5, over sine of angle C, which is 62. Okay, now if I'm trying to figure out what B is, I would definitely urge you not to do the calculation yet. Do one calculation at the end if you can, and then round once, because if you start rounding 2-3 times in a question, you're going to get your answer is going to be too far off. Okay, so if I want to get B by itself, I just multiply both sides by sine 52. So when I multiply this by sine 52, that cancels out the sine 52 on the bottom. And over here, I'm going to be multiplying by sine 52. And that's still over sine 62. So kind of a weird equation. I've got two sine calculations in the one equation. So please practice doing stuff like this because every calculator is different. Some you can put the whole thing in. Some you'll have to, like if I'm doing this on my iPhone calculator, what I would do 52, then the sine button, then times 2.5 equals, and then divide by 62 sine equals. So it's a little more numbers keys to be pressed if you have a calculator like that. Okay, so if I'm doing this on the calculator, the answer I get is if I round this, it's going to be equal to 2.2 because it says round to the nearest tenth. So, and then I think, well, what's the units? Well, I know that side was kilometers, so all the sides would be kilometers. Okay, so are you done? Not quite, because this doesn't really answer the question. We invented this, so now we turn it back into answering the question, how far apart are the two locks? Therefore, the two locks are 2.2 kilometers apart. Okay, always important. Word questions deserve word answers. Okay. All right, let's try another one here. This time they don't actually give us a picture of a triangle, so it always makes it a little bit more difficult. Let me straighten this out a bit. Okay. In acute triangle TUV, it gives us side TU, it gives us side UV, so it gives us two of the three sides, and it gives us one angle. So unlike the last question where they gave us two angles and we got the third for free, we're stuck at only one angle. And the question is to find the measure of angle V. Okay. Now, whenever you're drawing a triangle from scratch, it's pretty hard to tell the shape of it just by reading this out loud. So try to be as close as you can. But for me, it's the calculation that's the important thing, not so much the picture. So if I'm doing this picture, this may or may not be close, but I'm just going to put it here. And the one thing I'll start with is angle T. So if I make that somewhere close to being 31 degrees, well, that's good enough then, right? So then I've got T, U, and V. Okay, so it says TU is 11.1 centimeters, and UV is 5.8. Now, does it matter that, if this is a little bit off? No, not at all. Okay, so as long as you got the information in the right spot in the triangle, that's what's important. Okay, so if I'm asked to, what I'm asked to find is angle V. So put a little question mark there to remind myself. Okay, the first thing I do is I say, is this a right triangle? And it's not. Well, it might be, but we don't know, right? All we know is this is 31. So you can never assume or hope that it's 90 degrees. If it doesn't tell you there's a 90-degree angle, you can't assume there's a 90-degree angle. So this question, you'd have to use the sine law, at least try to use it. Okay, so we've got to the point where we're going to use the sine law. Now we have to figure out, do we have enough information? So I look at the picture and I go, do I know a side and its opposite angle? The only angle I know is this, and I do know the opposite side. So there's my complete ratio. And then do I know one other piece of information? Yes, I do. I know that side there. So I'm going to go ahead and I'm going to put my equation in. Now in this case I don't have ABC, I have TUV. Does that make a difference in the formula? No. Okay, just replace ABC with TUV. Now, do I use, which version of the formula should I use? Should I use the one with the signs on the top or the signs on the bottom? Again, you have to figure out what are they asking for. We want to know angle V, so that says I want to put the signs on the top. Okay, so I'm going to start off by saying what we want to know is angle V. So I'm going to start off my equation with sine V over little v. Okay, now I'm going to save myself some time. I don't need to write out all three ratios. This one I knew we were going to have to use because that's what I'm trying to find out. The other ratio has to be the complete ratio, and there's only one of those, and that's this side, this one here. I don't know anything about u or angle u or side u, so there's no way I could even think about using that. So I'm going to use t as my complete ratio, so sine big T over little t, and now I just plug in what I know. So I know side V is 11.1, and again, don't put the units in, just add them at the end. Make sure they're the same units, of course. And that's going to be sine T, which is 31, over little t is 5.8. Okay, and then the first thing I want to do is get sine V by itself, so I'm going to multiply both sides by 11.1. So that's going to be 11.1 sine 31 over 5.8. Okay, now you could do this and you're going to get a decimal. If you do the calculation at this point, make sure you write down your answer to at least 4 decimal places. People round to 1 or 2 decimal places, the angle is going to be way off. Okay, but what I would recommend is not do the calculation yet. How do we undo sine? Well, we do sine inverse. So we're going to do that here as well. So if I do sine inverse of both sides, I get angle V is equal to sine inverse of this whole thing here. 11.1 sine 31 over 5.8. And this is where you do your single calculation. So if I'm doing this on my iPhone, it's 31 sine times 11.1 equals divided by 5.8 equals, and then sine inverse. Okay, and it's going to be rounded to the nearest degree, so that works out to 80 degrees. Now, do I have to have a word statement for this? Well, the question was find the measure of angle V to the nearest degree, and I've done that. So I don't need to just say, therefore the angle V is 80 degrees. I've set it right there. Okay, now that's a little bit different than up here, because the question was how far apart are the locks. This doesn't really answer the question, so I had to put it into words. Okay, so hopefully that gives you 2 examples of using sine law and the kind of the thinking that you have to do when you're creating the equation and solving it. Okay, so make sure you try some of the homework questions here. They start off with some just basic, here's a triangle, find a side or an angle, and then you get into some word questions like this where you have to draw the triangle and interpret your answer. Okay, so we're going to have one more lesson this week on Wednesday, and that's the lesson on something called cosine law, okay, which goes along nicely with sine law. And there's going to be a couple of situations where sine law, you don't have enough information to use sine law, but you can use the cosine law. So this will be our last gasp attempt at finding a side or an angle on a triangle. If we can't use sine law, we're going to try to use cosine law. So that'll be the final lesson of the week, and that'll be on Wednesday. Okay. Don't forget to join me on office hours if you have any questions. Okay. Thanks a lot.